Hello everybody. Today is a little bit more about maths. So in my previous video, which is linked here and also below in the description of this video, I showed you how to solve the quadratic equations um, using the best known method where you calculate the discriminant delta and by using the formulas for the solutions of the quadratic equations. In this video, I will show you how to solve quadratic equations without these formulas. Okay, so that's pretty much the same equation which I showed you how to solve in the previous video, and now I will take use of these short multiplication formulas. They are, if you don't know them, I will show you quickly where they come from. So if you have a plus b squared, where a and b are some mathematical expressions, so this means like 5 squared means 5 times 5. So square means take the number and multiply it by itself. So here the whole bracket is being squared, so it's a plus b multiplied by a plus b. So this means you multiply everybody by everybody. So a times a is a squared, a times b is a b, b times a is a b, b times b is b squared. So here you have two same expressions, so it's 2ab, and you get this formula. In a completely analogous way, you can also derive this formula. So now, how do I use them here? So here it's my equation, and let's think of these two terms as about these two terms. Okay, so that means a is x and b is 5 over 2. So I have x minus 5 over 2 squared. If I calculate this using the formula, I get x squared minus 2 times x times 5 over 2. So 2 cancels out, so you get 5x. But you also get plus b squared term, so plus 25 over 4, because that's this squared. But here you don't have anything like 25 over 4, so you need to subtract this because that's extra unwanted term. So now this is a creative way of writing this. And then you have also plus 6 and equals 0. Alright? So what's next? So this was like this. Okay? So now let's focus on this equation and let's have a common denominator. So I rewrite this, and here also let's have denominator 4. So it's 24 over 4. So here nothing changes, and minus 24 over 25 over 4 plus 24 over 4 is minus 1 over 4 equals 0. And let's move this to the right hand side of the equation. So you get x minus 5 over 2 squared equals 1/4. So now what's the number that being squared gives you 1/4? So it has to be 1/2 or minus 1/2. So you have that x minus 5 over 2 equals 1/2, or x minus 5 over 2 is minus 1/2. So if you solve this, you get that, so you move minus 5 over 2 to the other side, so you get x equals 5 over 2 plus 1 over 2, so it's 6 over 2, so it's 3, or x equals 5 over 2 minus 1 over 2, so it's 4 over 2, so it's 2. So here are the two solutions of this equation, and if you try to solve it in a standard method using delta, or you check my previous video, you will see that these are exactly the same solutions which we got before. Another example which I solved in the previous video was like this: x squared plus x plus 6 equals 0, and I will show you that I can solve also this one without any formulas. So here the first equation is relevant, so also let's think of x squared plus x as about these two terms. So then I write x plus 1/2 squared, because this again will be x squared plus x, because it's 2 times x times 1/2, so 2 cancels out, but I have also plus 1/4, so that's an extra term which I have to subtract, so that to have only this. Okay, so now this is the same as this, and I have also plus 6 here. Okay, so I will show this to you on the general case of the quadratic equation. So ax squared plus bx plus c equals 0. I will start by taking a out of the bracket from the first two terms. So it's a times x squared plus b over a x plus c equals 0. And now let's think of this bracket as these two terms. Okay, so in this case I have a, and this will be x plus b over 2a squared. So if I use this formula, I get again x squared plus b over ax, that's this, because 2 cancels out, but I get again the term b squared over 4a squared, so that's what I have to subtract, because I don't have such a term here. Alright, here square bracket ends, and here I have plus c equals 0. Okay, let's maybe divide by a so that we don't have it here. So in this case I will have x plus b over 2a squared, that's this, minus b squared over 4a squared plus c over a equals 0. Now let's have a common denominator here, so I keep this first bracket unchanged, and here 4a squared is a common denominator, so I multiplied the bottom by 4a, so I also have to multiply top of this fraction by 4a, so it's plus 4ac equals 0. And as before, I keep this on the left hand side and move everybody else to the other side, so it's x plus b over 2a squared equals, so this goes with plus and this goes with minus, so it's b squared, and let's take it on the as one fraction, minus 4ac. Okay, so this is because, you know, if I have 1/5 sorry, 3/5 minus 2/5, it's 1/5 because it's 3 minus 2/5, right? This is what I'm doing here. Okay, so now what? Now I have something squared equals this. So to solve it, I want to take square root of this. But okay, the question is if this is positive. So if I can take a square root of this in real numbers. So for a squared, the denominator is 2a squared. So this is some number squared. So here no worries. This is of course greater or equal 0. But on the numerator, the top of this fraction is b squared minus 4ac. So I don't know if it's positive or negative. But do you recognize this is actually delta, right? This is delta, as we defined it before. So now if delta is greater or equal than 0, then I can take the square root of this, and in this case it will be x plus b over 2a equals plus or minus square root of delta divided by 2a, because again if, for example, x squared equals 4, then x could be plus 2 or minus 2. So if you move, keep x on left side and move anything else to the right hand side, you get that x equals minus b over 2a plus or minus square root of delta over 2a. So you can take it on the one fraction, so it's minus b plus or minus square root of delta divided by 2a, and this is exactly the same formula for the solution of the quadratic equation using delta as we use in a standard method. So using this method which doesn't require actually any formulas, we can derive these formulas for solutions of the quadratic equations.